good. Just like the last one, super important that you get the big picture on this one. A new word, I don't think we've ever seen this word before, differential equation. It's nothing special. A differential equation is just an equation where elements of the equation contain derivatives. So you've actually seen it before, we just never. No, it's like this equation says dy dx equals. We've written that a lot this year, dy dx equals. So you've actually been writing differential equations. We just haven't used that word. It's just an equation that contains dy dx. So don't worry about that. Then it says let y equal f of x be the particular solution to this differential equation with this initial condition. Danica's chart is the best way to understand the big picture. So I have an amount, and the amount is represented by a formula y. It's just like the last problem. The amount was p. Here the amount is y equals something. We just don't know the equation. Or we can say f of x equals. Okay, same thing. Good so far. And then, oh yeah, please. What they're really saying is that the formula for the amount could be considered y equals blah, 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 or f of x equals whatever. Yeah, they're not saying that y, they are saying that they're the same thing. It's just two different ways of describing the equation. Does that make sense? 2 points. Then under the rate, we do have an equation. They give it to us. The equation for the rate's right there. So you say dy dx equals negative xy squared divided by 2. They also tell us that over here in the amount, if we knew this equation and we plugged into this equation a -1, we would get a 2 out. It's extremely similar to the last problem. The last problem we worked, they told us that p prime was like 1 minus 3 e raised to the -0.2 root t. And then they didn't give us an equation for p, so we don't know that. But they did tell us that p of 0 is 50. So you should see that the two problems are actually very, very similar as far as the information they're giving you. They're just using different words again. That's just how they try to get you off balance. Question? Very good at the big picture. Okay. It says here, find the solution. Now again, don't look at this and say, oh, I'm supposed to make y become f of x. That's not what they're saying. They're saying the solution, the equation here, could be y equals something, or you could think of it as being f of x equals something. Either way. So we're supposed to find this equation. The solution to the differential equation, and our equation has to work in this manner. So we're just trying to find, we're doing what Colton wanted to do. We want to go backwards. We want to find the antiderivative. Okay? Questions on the big picture? Okay, there is one added caution. In this problem, the derivative only contains the input variable t. And so it does appear that there might be a way to go backwards with an antiderivative to find p. Turns out you can't. That's going to happen here and there in the test. This one's much more unique. This one contains both an input and an output variable. So you actually cannot simply find the antiderivative. So everybody needs to memorize the following. When you have a derivative formula or a differential equation which contains both input and output variables, you can no longer just find the antiderivative to find this equation. You have to use a special method that I have named the SASSY method. Okay. So you need to memorize that word, that acronym. When you are trying to get from an equation for the rate to an equation for the amount, this is the technique you're going to have to use if this equation for the rate contains both input and output variables. You cannot just do an antiderivative. The mathematical description is we're using a technique known as separation of variables. But I found that this acronym is more helpful, to be honest. So, question? Cool. All right, so here's how this acronym works. Let's copy this over so we get some space. So any questions on the goal of the problem? The goal of the problem is they've given us this equation. They're asking us to find this equation. So they're giving us the equation for the rate. They're asking us to find the equation for the amount. So our ultimate answer will be y equals something. You guys nodding is helpful, thank you. So I write down the equation I start with, dy dx. Okay, here's the sassy method. The S stands for separate. You need to separate input and output variables. So S stands for separate. You need to separate the input and the output variables. Easiest way to do that is always begin by multiplying both sides by dx. So I multiply both sides by dx to start with. That's always the first step in the sassy method. Multiply both sides by dx. Or it might be dt. Depends on the problem. Next thing, I don't really care about the 2 so much. Other than I don't really like denominators or fractions. So I'm just going to multiply the 2 across. You can choose. That doesn't really matter. I just don't like fractions. So. Okay, question? Oh, please.
How'd you get the negative x squared?
Your printout might not be very good, but you just started with that. Oh, huh. Shouldn't be squared. I don't have any idea. No clue. Yeah, I don't blame them. Nicely done. Sorry about that. Much better. But yeah, I'm trying to make more mistakes so you can collect more tickets. So, just kidding. Okay, we good to hear? Okay, we're trying to separate the variables. Remember the goal of the problem is we want to do a bunch of steps and end up with over here y equals something. So I just naturally want the y on the left and the x on the right. So I'm going to divide both sides or multiply both sides by 1 over y squared. So I end up with this. Questions? Awesome. Okay, we've finished the first step. The variables are separated because there are only output variables on the left and only input variables on the right, and you don't really care where the constants are. They just kind of go wherever. Questions? Awesome. The A stands for anti-differentiate. So first separate, then anti-differentiate. So we're going to apply the antiderivative operator to both halves of the equation. So they go like this, and they go like this. By the antiderivative operator to both halves of the equation. Okay, don't make the mistake of thinking you use the ln rule here. Because y is squared, you cannot use the ln rule. So I first will move the y squared to the numerator. So I have antiderivative 2 y to the negative 2 dy equals, here I just have, actually I don't need the antiderivative, I can do this one. So there's negative 1, and this would become x squared over 2. Question? Please.
What turned into -1?
So, negative x really doesn't mean negative x. It really means negative 1 multiplied by x. So to find this antiderivative, I just wrote down the negative 1. And then with x, it's x to the first. So the antiderivative becomes x squared over 2. 2 points. There you go. Okay, cool. This other side. So the 2 is a constant, so I just write that down. Y to the negative 2 is going to become y raised to the negative 2 plus 1 divided by negative 2 plus 1. That's going to equal negative 1 x squared over 2. Question? We have finished the antiderivative step. Right? We do need to, like cleaning this up will help. So this becomes 2 y to the negative 1 divided by negative 1, which means I think I would prefer to write negative 2 divided by y to the first, just to get rid of the negative exponent, then negative 1 x squared over 2. Question? Sweet. Remember the big picture. The goal of this problem is to ultimately end up with y equals something. Okay? And the idea is that once we have this formula, if we were to take the derivative of this formula, we could do some rearranging and get this formula. Which means this formula for y could have ended with plus 10, or minus 3, or plus 0, or minus 8. Because when we take the derivative of this formula, this will get lost, because the derivative of any additive constant will be 0. So I have to remember that there could have been, as I'm working out what y is going to equal, there could have been a c here of some value. So make sure, just like we did with antiderivatives, I said, do all the steps, then once you've kind of done everything, don't forget you can have a plus c. Questions? Please, what?
So you just do that to the right side, right? Because there's like an equal sign in the middle. So you just do the right side.
The way to think of it is really big picture. That, like, think back to here, Monet. We are trying to find this equation. Y equals something. And if we find this equation and take the derivative, we're going to get this equation. So this equation for y could end with plus 7. And when we take the derivative of this, this will become 0. It's like lost. So we're trying to come backwards. So there really aren't two constants. Like, we're just finding one equation. And that equation could have...
Sorry, it's just confusing because there's like 2 equal signs. Because y equals dy or dx equals. Or, I don't know, I feel like...
No, keep talking.
I feel like there's 2 equal signs. Like, there's the one in the middle, but then...
The one here, you're saying?
The other page.
Well,
The other page.
Yeah.
Keep talking. Oh, gotcha. Like, this is where I messed up. Time to pay Monet a ticket. I see why you're confused. Yeah, that's my bad. I should not have done that. I'm getting pretty good at this making mistakes thing. See if this makes better sense for me. There really is no equal sign here. That is my error. We had this equality, these two things being equal. We find the antiderivative, so now these two are equal. And now this one I just got a little bit lazy. This would still equal this. Okay with that. So then these two are equal. But what I'm anticipating is that I'll eventually do some rearranging, and I'll get y equals something. And there will be a possibility of an extra number over here. So I'm just kind of throwing it on now. Is that better?
Yeah, I was thinking of it as like, I was confused as like y equals -2 or y equals nothing.
Correct. No, it's very good. Yeah, there was no y equal over here. That was just my mistake. That's really well done. Good job. You really could. The reason I put it here is because I know the final result needs to say y equals something, so I want everything on the right anyway. 220. Anyone else? The C doesn't really need to be anything that bothers you. It's just an afterthought. It's like we've done the antiderivative, we just remember to put plus C. That's all. Pretty good. Cool. Okay, so okay, we've done separate, we've done anti-differentiate. I wanted the memory to be more permanent, so I wanted each of these words to end with the sound 8, because we've got separate, anti-differentiate, so I had to make up a word. Constantate.
Nice.
Oh, it's a good word. It's a verb. Constantate. It's a verb. It means to find the constant. Find this. Constantate. It's okay. It's a good word. So,
That's sick.
That's sick. To find the constant. Constantate. Okay. Did I talk to this class about how many points you will have to earn to get a 4?
Yeah.
60. Some years 58.
When you say 60, do you mean 60%?
No, 60 points
How many, it's out of 100?
out of 108. It is approximately, right, yeah, it's approximately 55%.
Oh.
Oh, yes.
Seriously.
So what's a case for
3 is about 44%.
So you can get 44% most times, you still got around 6 points.
Correct. That's why. Hey, I got it. So key things to remember. Look, listen, key things to remember. Keegan is correct. 55% is typically a 4. Some years 54%. Some years 56. It doesn't change a lot. And don't panic. 56. Oh no! Celebration. He's like 55%. Yeah. Oh no, 56. So much harder. Things to remember. Listen. Things to remember. No, that is accurate. And actually, my bar is set a little bit high because I would much prefer that you shoot for this and only have to hit this. Is that fair?
No, I agree.
Yeah, you understand that, right? The other thing I want you to remember is last year, the students who left this classroom on the day of the AP test, 91% of them passed the test. And listen to this number. I'll say this a lot between now and May 5th. 70% of those who passed got a 4 or a 5. Okay? So if you just stay on the track I'm trying to keep you on, if you don't fall behind, you just stay on the track, you'll be fine. You really will. The key is what we've been talking about today. The key is big picture. Like if you understand the big picture, the little steps will come, and really without too much difficulty. People have trouble when they try to do it the other way around. They just say, I don't care about the big picture, show me the steps. Then you have a lot of trouble on the AP test because they're very good at disguising things.
I'm excited for the review days because I think it helps to connect everything together, like what you're saying with the bigger picture. Because I feel like right now when I try to think of everything like separate ideas, I just get confused. But I think like being able to go over everything, it will just make a lot more sense. Consolidate.
Oh, yes. One thing just to kind of let you know where we're headed. So really a point of optimism, just like what Keegan noticed about the 55%. I don't think I've ever had a student come back to visit me who said, you know, oh wow, I missed all the hard work and the tears and the pain and the suffering, because it's hard. Calculus is. No one ever says that. Like nobody, you don't, but I've had a lot of students say what Meredith is talking about. They miss that feeling of honestly having a year's worth of like very high level knowledge, not kind of casual knowledge, like stuff that took effort to learn. They miss knowing that because it feels really, really good when I start putting AP questions on the board from any point in the year, and they're questions you have never seen before in your life, and you're like, I don't know what to do. Then you kind of just take a deep breath and go, wait, remember flashcards. Oh yeah, and then you start working, and a few steps later, I got it. Look, I promise you, that is an amazing feeling. It's like your brain just lights up because it just loves the feeling that you understood something and you were able to solve something. So no, it's a good, it really feels good. It's a lot of work between now and May 5th, but it really feels amazing. It really does. I don't do reviews. Everyone falls asleep when I review. So we practice. And then as we practice, you'll have questions that will just come up, and then we can talk about it. So yeah, we're getting very close to just starting to practice the whole year. So this is the last homework practice.
Oh, wait. Are you serious? Are you serious?
I don't want to.
Now listen, hey, listen. It doesn't mean it's the last thing I have to have you do at home. You understand that? Because there's just no way to get you ready. Sorry. You know, I keep 55, 56 homework packet, do stuff all I know. So, look, yeah, there's no way to get you ready for May 5th just with class time. There just isn't enough time. So there is work to be done at home, but this is the last learn a whole packet of new concepts. Like there's no more. Like we may have kind of random here or there something, but this is the last big packet.
How important do you think it is to know certain terminology? Because when I'm at Khan Academy, there's some terminology that I've never heard of, and then as I would look into it, I'm like, oh yeah, we've been taught that, but I don't know.
Don't stress about that. As we practice, different teachers do use different terminology, and so he'll do that. Yeah, don't worry about that.
Okay.
Yeah, as we work together, you'll be fine. Okay, we good to hear? That was a little bit of a diversion, but what I want to bring up with the 60 points is this. This is an FRQ, okay? So far, it will kind of vary from problem to problem, but so far you've earned between 2 and 3 points for getting to here. Just to kind of keep you aware.
So you would lose points if you don't have the C in this.
You do have to have a C, yeah. At this point, we have to say, oh wait, there's a C, but this reminds you, because we can't constantate if there's no constant to be found. So,
Did all step 3 was without even C?
no.
Oh, I was going to say.
No. That's kind of the first part of step 3. Now you need to find the numeric value of C. Okay, look out. Okay, finding the numeric value of C is really, really easy, and it is always worth 2 points. So that's a good thing to do. Like you want to find, hey, I'm trying to remind everyone, there's 108 points possible. Your goal should never be to get all the points. That's the wrong approach. Your goal is to get to 60 as fast as you can. Okay? So you want to do easy things before you do hard things. Finding the C is really easy because remember the big picture. Back to here. We're trying to find y equals something plus 7 or whatever. But whatever equation we find, it has to be an equation where if you plug in -1, you get 2. So if the x is -1, the y has to be 2. So look how easy this is. I have an equation. It has an x and a y. When the x is -1, what's the y supposed to be? 2. That will leave only one unknown. We can find C.
Yes.
This is how we constantate. So,
Constantate.
yes, please share that with all of your English teachers. New verb learned today. Make sure you always replace variables with a set of parentheses to avoid mistakes. So we have -1 equals, -1 squared would be +1. This is -1/2. Plus C. Question?
C. Nice.
Are we good? Perfect. So add this across. I discovered that C is equal to -1/2.
Yeah. Constantate.
Now, warning. I told you way back up here that it doesn't matter where the constants end up. However, depending on how you move the constants around, you'll often get a slightly different value of C. It doesn't matter. They'll give you full credit no matter what, as long as you don't make a mistake. So the C I'm getting here might not be the same as the C you see in the back. Don't worry about it. If you're unsure, you can ask me. I'll help you. But the C will vary sometimes depending on how we did the steps, the prior steps.
So it's the G is that
No. Back here, we're starting with a rate. When they say solve the differential equation, they're asking us to find this equation.
so I see y equals x.
Yeah, y equals something, and then we do know one part of it. We found the C. We just have to find the rest. Points for Ava. Okay.
Say that one more time.
Uh-huh.
The C.
This part or this part?
Well, I just don't understand why it would
Keep going.
fluctuate.
Oh. It will fluctuate depending on where you put the constant. I don't have a good way to explain that. It's more just like I just know
You
from
did it
experience. Like I put the 2 over here.
Yeah, you did like the negative.
If I left the 2 here, I'm going to get a different value for C. That's all. Just because of where I move
It's a nominal
constant.
difference.
Say again.
It's a nominal difference.
It's a distinct difference, but it doesn't matter. Here's why. The goal of the problem is to get the final equation. By the time we get to the final equation, all of those differences will evaporate. And I can't explain that very well other than just tell you I know by experience that depending on how I solve the problem, I get different values for C. But my final answer is always the same. So that's all I care. Okay. So on this problem so far, we've earned 4 points. I think 5 actually. So that's a pretty big chunk. I mean, that's 1/12 of what you need. Nearly 10% of what you need to get a 4 is earned in one problem.
So just doing like if you all problems like this.
Just do the right problems. Yeah. Now, you never know, so all you have to focus on is as you're working, if things are going smoothly, you keep working. If things hit a roadblock, you just move on. Just keep moving. Julia, please.
How many problems are you doing on the test?
So you're going to have 30 questions that are multiple choice, and you can't use your calculator. That section historically has been more difficult. And so really, if you can get like a third of those, up to a half, you're doing great. That means like half of them, you don't care. You just get the ones you can. Then you have 15 questions multiple choice with your calculator. Now I say historically because you never know, right? But historically that's been a lot easier. Like I've had students come back and tell me, oh, the calculator section on the multiple choice was like cake. Like I just flew through it. Like there was one I couldn't figure out. So people tend to pick up a bunch of points there. FRQ, there'll be 2 with your calculator. FRQs are divided up into like little questions though. Kind of like this one. I mean, this alone is worth 6 points.
Like A, B, C.
Yeah, it's like A, B, C, D, and then each A, B, and C is worth different amounts. So you have 2 of those, but they're worth a total of 18 points. Then you have 4 FRQs, no calculator. That would be a total of 4 times 9, 36 points. Sam?
Does it tell you how many points each question's worth?
It doesn't, but we'll practice so much that you'll get a pretty good idea. Like you just learn by experience about what they award. You won't know for sure, but you'll have a pretty good idea.
Are there like breaks in between those, or do you just finish one and then you go right to that?
From the multiple choice no calculator to the multiple choice with your calculator, no break, other than to seal the booklet and get the new booklet, open it up and go. Between the multiple choice and the FRQ, they let you come out for snacks, go to the restroom, like 10 minutes I think is the official break time. Similar, yeah. So they have a break in the middle. Then you'll do the FRQ with your calculator, no break, you just merge right into the others. No. Yeah, it's nice on the multiple. They did, a long time ago they did, but no more. But the multiple choice section, you always want to bubble everything. So you do what you can, you try to keep moving, you don't want to get stuck. You have a watch, like I recommend everyone get a watch, like the old-fashioned kind, so you can use it for the unit circle. And then with 1 minute to go, like they'll tell you when 10 minutes remain. 1 minute to go, you go, time to quit, just get all my bubbles in. Better to guess than not, because there's no penalty.
Do you give us an amount of time for each section?
The 30 questions, no calculator, you get, 30 questions, no calculator, you get 60 minutes. And those can be hard questions, so your key is to not get stuck. Just keep doing what you can. And it's going to feel like you're missing lots of them, but it's okay. If you miss half of them, you're still doing great on that section, you really are. Then on the calculator section where there's 15 questions, they actually give you 45 minutes. That's one reason people tend to find that easier. Then you have 30 minutes on the 2 FRQs with your calculator, followed by 60 minutes for the 4 FRQs without your calculator. But the rules actually allow you to go back to the first 2 FRQs, you just can't use your calculator. If you need to write something or whatever, you can still do that.
So it's kind of like in the English or history where they have the essays and they like have a recommended time, but they let you spend as much time as you want.
Kind of. The difference is you got 30 minutes where you can use your calculator, then you have 60 more minutes where you can work on any of the problems, just you cannot use your calculator at all after the first 30 minutes. But in FRQs, even ones that require a calculator, there are sometimes questions where it's like just writing that you might need to go back, but I don't think people typically go back, but you could use. Other questions?
Yeah, FRQ is worth more points over a problem.
No, it's divided evenly, and here's why. There's 45 multiple choice questions in total. Each of them is worth 1 1/4 points. So those two multiplied together give you 54 points. There are 6 FRQs. Each of the FRQs is worth 9 points. So that's a total of 54 as well. So they're divided evenly. Okay, you gotta hurry a little bit. Sorry, I got diverted on some questions, but the questions are good, so don't stop. Is everybody good here? Look, okay, remember the big picture. We are trying to find this equation. And we're really close now because we have this equation right here. This one. And we know this value is -1/2. So I'm going to go to a new page and write that down. Copy this over. There we go.
How you do the I?
Now I do I. First one is separate, anti-differentiate, constantate. Last word must end with 8. No, we don't. We're going the other way, right?
Yeah.
We don't want to integrate.
I just threw it over this.
But what's the goal?
To get the equation.
Say it.
Yes!
Say it, Caitlin. Caitlin, what's the goal? Say it. Yeah, what are we trying to isolate? We're trying to get Y alone. We're trying to get the Y alone. Trying to get the Y alone. So, negative 2 over Y equals negative 1 x squared over 2 minus 1/2. Question?
Are you always trying to isolate the Y? Yeah.
Well, the output variable. I've seen it's not real common, but I did see a problem one year at Cooper that looked like this. So the differential equations start with dw dt. I think I've seen one that was db dt. It's the output variable you're trying to isolate. No, because I have 2 reasons. One, I don't want to give up a week away from my family. And 2, I don't want to grade. It sounds like the worst job ever. So what I've done instead is I have spent a lot of time studying what is published by AP as far as how they grade. So I have, well, and also I just know how many students of mine pass. So I have great confidence that what I'm telling you is, no. Wait, what was your last year? Last year, 91% of the students who left, well, I think there's 2 things you need to consider. Look at me. Be very careful when you ask people like pass rate. In my opinion, you need to ask 2 things. Like how many are taking the test? It's really not that hard to get a high percentage if the number taking is low. You just weed everybody out. Like I know teachers not here, but in other schools who do that. They tell people, don't take the test. You have no chance. Seriously, like no one does that here. But if I did that, I could get to about a 99% pass rate. Piece of cake. So what I look at is how do I get, exactly, how do I get this number high, like the number taking to be as high as I can get it, and then the number passing to be as high as I can get it. So last year, 202 students left my room, went down, took the AP test. 91% of those students passed. 70% of those who passed got a 4 or a 5. Nationally, about 57%. Okay. Maybe 58. Right about it. Well. It was impressive when you said 57, not when you say 58. So. All right. I gotta hurry. It's a really good day, but we kind of got bogged down a little bit. I need to isolate the Y. So first thing I'm going to do is I'm going to get rid of this 2 here. So I'm going to multiply both sides of the equation by negative 2. So when this, oh no, I have negative 1. I'm going to divide, thank you. So I'm going to multiply both sides by negative 1/2. So we'll multiply both sides by negative 1/2. So that'll give me 1 over Y. The negative 1/2 will have to distribute. I feel like I made a mistake somewhere in this problem. So negative times negative is positive. I'm going to get x squared over 4. And this will become plus 1/4. We need to get Y alone. We're close. Look at this, please. Algebra is a lot easier if you can think of things in chunks. This is the same thing. like I'm trying to get y alone, right? There's no y over here. So I'm just going to think of that as just a big chunk. So I'm going to multiply the y across, then divide the age. Now I'm done. The answer in the back probably does not look like that, but it doesn't matter because on the AP test, you are not required to simplify your answers into any form. So that's good enough.
Yeah, just re-explain that last step you just did.
Are you kidding here?
Yeah.
So what I did,
The one over.
gotcha. So what I did, Christian, is I said, I don't really need to think of this as individual pieces.
Oh, you just times the y over.
Right.
divided
Does that make
by-
sense? Yeah, good work.
Nice.
Please, Jake. You can. So what I showed may not have been helpful. Sorry. I had high hopes for it, but it didn't really work out. It didn't really work out. Okay. Does that make you good? Any other questions here? Okay. We got a couple of minutes. I got to explain one more thing. So